Hello and welcome. In this lecture, we are going to use Python for operation on sets. The first operation that we are going to perform is union of sets. We know that union of sets A and B results in a set which are having elements both from A and B. Now suppose that we have a set A having elements from 1 to 4 and set B having elements from 3 to 6. We can find A union B as follows: A dot union B, and if we print the result we get like this. Set A is having elements 1 2 3 4, set B is having elements 3 4 5 6. Union of A and B is having elements 1 2 3 4 5 6. We can check the properties of union of sets as follows. Suppose that we have a set A having elements 1 3 5 7 9, set B of elements 1 4 9, set C of elements 2 4 6 8 and 10, and we can define a universal set having elements from 1 to 9. We can check the associative law, which says that A union B is equal to B union A. So we can check whether this is true. We take A union B and we check it whether it is equal to B union A. And if we check it, it shows that it is true. We can check the law of identity, which says that A union with an empty set gives the set A itself. So we can check whether this is true, and the Python says that this is true. We can check the law of U, which says that A union with the universal set gives the universal set itself, and we can check whether this is true, and Python says that this is true. We can check the idempotent law, which says that union of a set with itself gives that set itself. We can check whether this is true in Python, and Python says that this is true. The next operation that we are going to perform is intersection of sets. The intersection of sets A and B results in a set having elements which are common to both A and B. Again, suppose that we have a set A having elements from 1 to 4 and set B having elements from 3 to 6. We take intersection like this: A dot intersection B, and if we print the result we get the common elements as 3 and 4. We can check the properties of intersection as follows. Suppose that we have a set A having elements 1 3 5 7 9 and set B having elements 1 4 9, set C having elements 2 4 6 8 and 10, and we can define universal set of elements from 1 to 9. We can check that this is commutative, so A dot intersection with B should be equal to B dot intersection of A, and Python says that this is true. We can check whether this is associative, so we take A with intersection B and intersection C, and we want to check that whether this is equal to A intersection B intersection C. So A dot intersection B dot intersection C should be equal to A dot intersection of B dot intersection C. These two values should be equal, so if we check it we get that this is true. We can also check that intersection of a set with the empty set is the empty set. So A intersection with an empty set gives the empty set. We can also check the law of U, that is A intersection with the universal set gives the universal set itself. So this gives the set A itself, and Python says that this is true. We can also check the A intersection with itself gives that set itself, and Python says that this is true. Now we know that these two sets are disjoint if their intersection is an empty set. Suppose that we have set A having elements 1, 2, 3 and set B having elements A, B and C. We can print the intersection of these sets and we can also check whether A intersection A and B are disjoint. So A dot is disjoint B. So the first print statement says that the result of A intersection B is the empty set, and the second print statement says that A is disjoint B is true. The third operation that we are going to perform is the complement of a set. Since complement of a set requires the presence of a universal set also, Python doesn't provide a ready-made function for the complement of set, but we can create a function. And we can do this like this. We can define complement which takes a set A and U and return A U minus A. Now suppose we have set A having elements 1, 2, 3, 4, and for this set we can create the universal set as X for X in range 1, 11. So U is a set of elements from 1 to 10. Then we can find complement A, U, and if we print the result, it gives this result. A complement is 5, 6, 7, 8, 9 and 10. Now properties of complement. We know that A in union A complement is universal set and A intersection A complement is an empty set. We can check that. So we take A union of complement of A and we check whether this is equal to U. Python says it is true. We can also check A intersection complement A, U, and we can check whether this is equal to empty set. Python says that this is also true. We can check that the complement of a complement results in the set itself. So we can check complement of A, U, and we take again the complement of this set with U and we check whether this is equal to A. Python says that this is true. Now we can check law of empty set and universal set. So complement of an empty set complement of the empty set with U gives the universal set and complement of the universal set gives the empty set. We can verify the De Morgan's laws. The De Morgan's law says that A union B complement is equal to A complement intersection B complement, and the second De Morgan's law says that A intersection B complement is equal to A complement union B complement. So we will check it like this. We will take A union B and then we will take complement of A union B with U. Then we will check whether this is equal to complement of A U complement of B U and the intersection of this. Python says that this is true. We can check the second De Morgan's law as follows: A dot intersection of B, then the complement of that with U should be equal to complement of A with U union of complement of B with U. So the Python says that this is true. We can find the difference of sets as follows. Suppose that we have set A having elements 1, 2, 3, 4, 5 and set B is having elements 4, 5, 6, 7. Difference is of sets. The sets is simply A minus B and we get the result 1, 2, 3. One of the properties say that number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Therefore, we can check this whether this is true. So length of A dot union B is equal to length of A plus length of B minus length of A dot intersection B. Python says this is true. That's all for today's lecture.